let's do some problems on density. So here are some problems we can work through, and hopefully by the end of these we'll have a grasp of how to approach these density problems. The first question says, what is the bone density in grams per milliliter in a healthy female if a 3.50 milliliter bone sample has a mass of 10.15 grams? So they're asking for the density. Now remember, density is the mass over the volume. So it's how much stuff you have in a given space. Now, you can remember this equation with a cute little mnemonic. If you take those first letters, so you just use the symbols, D for density equals M for mass over V for volume, then you take that fraction bar away, you can see how the M and the V there kind of look like a heart. And that heart represents how much everybody loves density. Alright, so mass here is going to be in grams, volume is going to be in milliliters, and the density units are going to be in grams per milliliter. And those are useful units to know, because sometimes they don't use the explicit words mass, volume, or density in a problem, they just give you the units. So by knowing those units, you can know which variable a number represents. Alright, so here they're saying what is the bone density, so we're looking for density. The next number they give us is 3.50 milliliters, and because it's in milliliters, I know it's the volume. So I'm going to put that on the bottom of a fraction. And then it says if the bone sample has a mass of 10.15 grams. And when I see the grams, I know that that's a mass, so I put that on the top of my fraction. And from here, I just plug it into a calculator. 10.15 divided by 3.5 gives me 2.9. And the units you're left with are grams per milliliter. Neither of the grams nor the milliliters canceled out, and so you're just left with grams per milliliter. And that's it. That would be the density for those bones. On another problem, what is the average density of the human body if it has a volume of 68,950 milliliters and a mass of 70,000 grams? So again, density equals mass over volume. And watch out for the units. Now as we read through this, it says what is the average density? So we're looking for density. And the next thing we run across is if it has a volume of 68,950 milliliters. So because those are milliliters, that's a volume, I'm going to put it on the bottom of the fraction. And a mass of 70,000 grams. And because those are grams, it's a mass, I'm going to put it on the top. And from here, you just plug it in a calculator. 70,000 divided by 68,950, that should give you 1.015, and your units are grams per milliliter. This one says a 105 milliliter sample of air has a mass of 0.1344 grams. What is the density of the air? Well, density equals mass over volume, and so the first thing they give us here is 105 milliliters. That's a volume. I'm going to put that on the bottom of my fraction there. The next number they give us is 0.1344 grams. That's a mass, so I'm going to put it on the top. And we're looking for density. What is the density? So D there. I just plug those numbers into a calculator. 0.1344 divided by 105. And that should give you 0.00128. And the units will be grams per milliliter. And that's your answer. This question says an empty container has a mass of 121.30 grams. When a 3.00 milliliter sample of gold is added, the total mass of the container and gold together is 179.26 grams. What is the density of the gold? Okay, well here they're asking about the density of just the gold. So we're going to plug it into our normal formula. Density equals mass over volume. But when we get the mass, we want just the mass of the gold and nothing else. And when we get the volume, we want just the volume of the gold and nothing else. Now here it says an empty container has a mass of 121.3 grams. So when we use this equation, we are going to want to do that just for the gold. That's not going to include the empty container. The empty container has 121.30 grams. But we're not going to take that mass and plug it into that formula, because it's not the gold. Then it says when a 3 milliliter sample of gold is added, the total mass of the container and gold together is 179.26 grams. And so that's the mass of both the container and the gold. So if we want just the mass of the gold, we can take the mass of the gold and the container, subtract the mass of the container, and we just get the mass of the gold. So in this case, it would be 179.26 minus 121.3, and that would give you 57.96. So now we have the mass of the gold. It's 57.96, and I can put that on the top of that fraction in that equation. They also tell us in the problem that the piece of gold is 3 milliliters, and so I can put that on the bottom of the fraction. So now they're asking what is the density of the gold? Well, plug that into a calculator, 57.96 divided by 3, and you have 19.32 grams per milliliter. And that's your answer, the density of gold. Here, this question says, what is the mass of a 0.25 liter sample of seawater if the density of seawater is 1.035 grams per milliliter? So, we know that density equals mass over volume. The first number they give us here is 0.25 liters. But notice how these liters don't match the units of density. The units of density have grams per milliliter. So we need to get this liters converted into milliliters before we plug it into the equation. So we'll take, first we need that conversion factor between those two units, between liters and milliliters. And that's that 1 liter equals 1,000 milliliters. Then you take that number that they gave you, do a multiplication sign, fraction bar, units on the top go on the bottom so they'll cancel out, and fill that fraction in with the conversion factor. So next to liters will go 1, going over the fraction bars like going across the equal sign, and on top you'll have 1,000 milliliters. Liters will cancel, and we're left with milliliters. To plug this into a calculator, you'd press 0.25 times 1,000, hit enter, divided by 1, enter. You should get 250 milliliters, and that is going to be the volume in the correct units. So we can plug that into our equation now. So that's going to go in that denominator there. The next number they give us is 1.035 grams per milliliter, and that's the density. So we can plug that in for the density. And they're asking us what is the mass. So that's what we want to solve for. Now here, the mass is, we want to get that m all by itself. Right now, it's tied to another number, the 250, and it's tied through division. So to untie it, you have to do the opposite operation. So the opposite of division is multiplication. And you have to multiply it by the same number that you were dividing it by, so 250. But if I do that to one side of the equation, I have to do it to the other. On the right side, those 250 milliliters will cancel out, and I'll just be left with the mass. And on the left, it's just going to be 250 times 1.035, and that would be 278.75 grams. Notice how the milliliters here cancel with the milliliters in the denominator of this fractional unit. So you're just left with grams. And we know that grams are the units that you use for mass anyway. So there you have it. This question says, what is the mass in grams of 172 milliliters of fresh water with a density of 1.000 grams per milliliter? All right, so we know density equals mass over volume, and they're asking for the mass. Then they give us 172 milliliters. That's the volume. I'm going to put that in the denominator in the equation. And then they give us a density. They say the density is 1.000 grams per milliliter. So I can put that on the other side of the equation. Now, we want to get that m by itself. Right now, it's tied to 172 through division. So I'm going to use the opposite operation, multiplication, with the same number, 172. If I do that to one side of the equation, I have to do it to the other. On the right side, it'll cancel, so I'll just be left with m, the mass. And on the left side, it's just 172 times 1, so you'd get 172 grams for the mass. And again, notice how those milliliters are canceling with the milliliters in the density. So that's your answer. This one says a life-size bronze statue of a human has a volume of about 68,950 milliliters. If bronze has a density of 7.8 grams per milliliter, how many grams of bronze would be in a solid life-size statue? So, we know that density equals mass over volume. The first number they give us is 68,950 milliliters. We can put that in the denominator in our equation. The next number they give us is 7.8 grams per milliliter. That's the density. I can plug it in for density in the equation. And they ask for how many grams of bronze would be in a solid life-size statue. Well, grams is mass, so we're going to be solving for mass. Now, the m is tied to that 68,950 through division, so to untie it, we're going to do the opposite operation with the same number. So instead of dividing, here we're going to multiply with the same number, 68,950. If I do that to one side of the equation, I have to do it to the other. On the right, those numbers cancel. I'm left just with the mass, m. And on the left, I would just plug that into a calculator. 68,950 times 7.8, and you should get 537,810. And the unit will be grams, because this milliliter here is going to cancel with the milliliter on the bottom of this fraction unit here. So, that's your answer. Thank you so much for your attention.